Hello everyone. Let's see a problem of physics, which is from the chapter Center of Mass. And the question is from the topic Spring block problems, which is a very standard problem. So let's see it. Two blocks of mass 3 kg and 6 kg respectively are placed on a smooth horizontal surface. They are connected by a line spring of force constant K is equal to 200 Newton per meter. Initially, the spring is unstretched. The indicated velocity are imparted to the blocks. Maximum extension of the spring will be. So here, two blocks are given, which are having masses 3 kg and 6 kg. So they are connected by a spring, which is the of the spring constant 200 Newton per meter. At the initial stage or the at the initial position, the spring is unstressed, so it is at its natural length. Then it has been given some impulse, or we can simply say it has some velocity, which 3 kg blocks has a velocity of 1 meter per second, and the 6 kg blocks has a velocity of 2 meter per second. So we are asked to find the maximum extension of this spring. So let's find this. We have two methods to solve this. First is the simply equating the half kx square is equal to half mu v relative square, which is a formula. But let's do it by a mechanical energy conservation, which is a basic formula of question like this. So since the net external force on this system, on this whole system is zero, we can simply apply the mechanical energy conservation. So A initial plus U initial, which is potential energy initial, is equal to K final plus U final. Now, the initial kinetic energy will be equal to half mt UCM whole square plus half mu U relative square. This will be the initial kinetic energy of this system. But the initial potential energy of the system will be zero because the spring is at its natural length. So there is no compression or extension. Hence, the potential energy is zero. Kinetic energy final will be half mt VCM square plus half mu V relative square. This is the final kinetic energy of the system. But there is also potential energy at its final stage because the spring will be at its extended form. So we have, let's take the extension of the spring as a x. So we will get the spring potential energy as half k x square. Now, as we know, the external force on this system is zero. External force on system is zero. So acceleration of center of mass will be zero. Acceleration of center of mass will be zero. And this implies velocity of center of mass will be constant. Constant. Hence, we can say the center of mass initial velocity will be equal to center of mass final velocity. So from here, as we can see this equation, this is our equation. This, so here we have half empty VCM square, UCM square, and here we have half empty VCM square. And since VCM is equal to UCM, so we can simply say that these are equal. So we have half mu v relative square is equal to half mu v relative square plus half k x square. Now the spring will be at its maximum extension when the velocity of the both of blocks relative to each other will be zero. Let's understand this. So first, the uh, firstly, this this block will be more compressed because the momentum of this block is more, which is 6 into 2, 12, and this is 3. So the velocity of this block will be reducing and reducing till attains its center of mass velocity, and this block velocity will be increase and increase until it acquires the velocity which will be equal to center of mass. Hence, at the center of mass velocity, the I mean to say the both blocks will acquire center of mass velocity. Then only it will be equal. The maximum extension will be possible. So at maximum extension, v relative of the both of the blocks will be zero because the both blocks will have the same velocity. Both blocks will have same velocity. So definitely their velocity relative will be zero. So simply this this part will also equal to zero because v relative is zero. So this also equal to zero. Now the part which we have now is half mu v relative. Oh, sorry, half mu u relative square is equal to half k x square. The mu is simply the representation of m1 m2 upon m1 plus m2. In our question, 3 kg and 6 kg blocks are given. So mu will be equal to half into 3 into 6 upon 3 plus 6. The u relative square will be equal to this block has a velocity 2 meter per second and this block has a velocity 1 meter per second. So we will add this block's velocity by doing the direction opposite. So 2 meter per second plus 1 meter per second. This direction 3 meter per second will be the v relative u relative square into 3 square is equal to half k x square. The k's value in the question is given as 200. So we will put that, and the x square, which is x is our the maximum compression of the spring. So half into 9, oh sorry, into 18 upon 9 into 9 is equal to 2 and 200, which we will get 100 x square, 100 x square, 9, 9, 4, 2, 9s are 18. So 9 is equal to 100 x square. From here, x square is equal to 9 by 100. So x will be equal to 3 by 10 meter, which is 30 centimeter. So maximum compression of the spring will be 30 centimeter. So this was the question. Thank you so much for watching.